स्लाइड पे जाइए सर थोड़ा, आप स्टार्ट से ही स्टार्ट करिए।
करो, ठीक है। So just I now start from the hypothesis. Hypothesis is a very
सर
important.
सर
Yes. हाँ बोलिए
सर, आप फर्स्ट स्लाइड पे जाइए और सर स्लाइड मोड कर लीजिए प्लीज। आप थर्ड स्लाइड पे हैं।
हाँ मैं यहाँ से शुरुआत करना चाहता हूँ, इसमें कुछ दिक्कत नहीं है ना।
अच्छा
It's
ठीक
the
है,
basic
ठीक।
foundations of the course. That's why I'm start from here. Okay. So first of all, we have to understand what is the hypothesis, because while we are conducting any kind of hybrid statistical or advanced statistical analysis in research, so first is hypothesis. Is a very important in our research. There is a two kind of hypothesis. One is the research hypothesis, another one is a statistical hypothesis. So in case of research hypothesis, a research hypothesis is actually tentative solution for a investigation. And that particular research hypothesis we can formulate through our literature review. So in a nutshell, in other words, we can consider research hypothesis is a theoretical hypothesis. Okay. Next one is a statistical hypothesis. Actually, whenever you go through any kind of research paper, you find out the statistical hypothesis. There is a two kind of hypothesis. One is a null hypothesis. Another one is a alternative hypothesis. So statistical hypothesis actually we conduct after the data analysis, after the data collection. When we have a data, we collect the data, we gather the data from our field. In case of suppose there is agricultural field, you going to apply some fertilizer and you want to understand, you want to investigate that what is the impact of the application of fertilizer on the outcomes. This is called the what? In sense, this is called the impact of fertilizer application on the agricultural production or the yield. So in that particular case, you go to the field, you collect the data from the farmers, then you are going to apply statistical hypothesis. So there is a two statistical hypothesis. One is a null hypothesis, another one is a alternative hypothesis. So null hypothesis means well, we are going to find out there is a no difference, no impact between the parameter and a specific value. Example बताता हूँ क्या है? Like you can take an example like that. There is a no impact of fertilizer. There is a no impact of fertilizer on the agricultural production. Alternative hypothesis, there is an impact of application of fertilizer on agricultural productivity. So this is called the null hypothesis and alternative hypothesis. Null hypothesis, no difference, no impact, no effect. The opposite sense we consider as a alternative hypothesis. So how can we judge this particular null hypothesis and the alternative hypothesis? It is actually based on the what? It is actually based on our value. Which particular test we actually going to conduct and what is the critical value of this analysis. One is a calculated value, another one is a critical value. So on the basis of your hypothesis, you may find out that the impact of the fertilizer actually increased the agricultural productivity. Otherwise, you may consider that the application of fertilizer may decrease the agricultural productivity. In a real sense, it's not happening. But in a case of, if you consider the law of diminishing rules or law of diminishing, you find out that definitely it may be happened when we consider, when we apply more fertilizer with respect to the actual soil condition. So in that particular manner, you can consider that hypothesis may be, alternative hypothesis may be three types. One is a not equals to, means there is a no difference. no difference, maybe the greater influence, or maybe the less influence. So this particular alternative hypothesis actually indicate the level of test, maybe the one-tail test or maybe the two-tail test. Maybe the one-tail test or maybe the two-tail test. So one-tail test means while we are considering greater than or the less than concept. Two-tail test means when we are considering the equals to, not equals to concept. Okay, so in that particular context, one-tail test and two-tail test, this is a very important while we are conducting the hypothesis. So one important thing is null hypothesis. Second one is a formulation of alternative hypothesis. Third one, which kind of test is it? Is it one-tail test or the two-tail test? One-tail test or the two-tail test? This is the very important for first step while we are conducting, while we are going to perform any hypothesis analysis. There is another topic, another important terminology which relates with the hypothesis testing. This is called the error. Suppose sometime we actually reject the true null hypothesis. Reject true null hypothesis means, suppose you are already mentioned in your thesis or research paper the hypothesis, objective also. But suppose your data set are limited. You actually not getting your desired result. Then you try to manipulate the result, and that manipulation actually making a trouble situation. That is the error. There is a two kind of error. One is a type 1 error, another was a type 2 error. Type 1 error means while you are reject the null hypothesis means you actually reject the true null hypothesis. When you consider, when you do not reject the null hypothesis, when fact is a false. Okay, false means null hypothesis actually not proved. Null hypothesis actually not correct, but you accept it. When you accept the wrong things, when you accept the false thing, this is the type 2 error, and in a statistical research, type 2 error is dangerous. So what is meant by type 1 error? What is meant by type 2 error? Type 1 error is rejection of true null hypothesis. True null hypothesis you reject, but you consider what? The false null hypothesis. False null hypothesis. Then it is called the type 2 error. So in a simple, here you find out a table. Type 1 error is rejecting the true H0 null hypothesis. Type 2 error, not rejecting the false null hypothesis. So formulation of null hypothesis. Null hypothesis means no difference, no effect. Then formulation of alternative hypothesis. If you consider equals to, there is an impact. There is maybe the greater impact, less impact. So in that particular case, we consider further one-tail test or two-tail test. One-tail test means there is a direction. It's maybe greater than or it's maybe less than. Two-tail test means there is a no directions. We only try to calculate or investigate hypothesis. There is a no impact, no effect on A, on B, on Y. And in consideration of result, we may find out another, must be find out another terminology which is a very associated with the research, that is called the type 1 error and type 2 error. So in a simple form, you reject the right direction, type 1 error, you accept the false one. You accept the false result. That is very dangerous in statistical research. Here is a level of significance is an important term. Why? because there's a lots of tables are there in case of ANOVA, in case of regression, in case of non-parametric analysis, like suppose Kruskal-Wallis test, different kind of test, Whitney-U test, different kind of test is a non-parametric test. But which particular test actually indicate statistically significant or insignificant? How can we judge? How can we judge whether my output is indicating statistical significant results or insignificant result? It is actually based on the level of significance. As a rule of thumb, we normally consider 5%. 5% means 5% chance allowed for rejecting true null hypothesis. So 0.05 level, 95%. That's why you maybe find out mostly the SPSS, they actually consider the 95% level of significance. The value is a 0.05. How? In a probability, in a general mathematics, 1 to 100%. Sorry, 0 to 100%. In probability, we actually consider, 0 to 1. So 100 actually indicating what? 1. So if you subtract 1 from 1 to 0.95%, that's why 950, you subtract the value is a 0, 5, 1, 0.0. So 0.050 means the 90% significant level. If your probability value, p-value, is actually 0.05, then you can say, or it's less than 0.05, then you can say, yes, the test is significant. The test is statistically significant. Otherwise, if the value is a what? Greater than 0.05, then you can conclude, interpret that the result indicating what? Insignificant result at 95% level. Maybe you ask question, sir, suppose a particular test may be insignificant at 0.05 level, but it's significant in where 10% chance means that 90% level. Can we consider it? I say yes. If you think that your result is important, your significance result is important in case of interpreting the real situation, then you consider the 90%, but never consider below the 90%. So as a rule of thumb, 95% is a standard level of significance. Mostly different kind of software packages, they actually consider the 95% significance level. But in case, if you find out that the value is near about the 0.01, then you can consider 0.1, then you can consider the result 0.1. 0.1, 1 minus 0.9. So you get the value 0.1. So if the p-value is less than or equals to 0.1, then also you consider your result indicate a significant result. Look at this is a particular example. How does level of significance actually affect the testing? Suppose in case of alpha 0.10, this is the 10%, means what is mean by alpha? Suppose your value, your test value, T is indicate the test value, G, this G actually indicate the what? This is the hypothetical value of what at the 10% level. It's a fixed value. You can extract this particular value at different level from the J table, T table, ANOVA table. There is a lot of tables. Okay, are there. So from this particular table, you can clearly extract the value. So here you think that one thing, if you look properly, first image, second image, and third image, what is the difference? To find out the difference of the width, this particular width of the critical region. So when you consider the 0.01 means 99.9% level, then critical region is less. That means you try to precise your research outcomes. You consider very, very nominal rejection level, very nominal rejection level. So you only allowed 0.01 percentage, 0.01 unit of error. So this particular calculation, significance of level, actually try to precise your result outcomes. Whenever you consider only the 1%, then the critical region is less, means your research result is more precious, more accurate as compared to the 90% and 95% level. So if your test value fall in this critical region, then you reject the null hypothesis. If your test value fall beyond this critical region, then it is called the fail to reject, not don't, is actually fail to reject null hypothesis. In a statistics, we actually interpret our statistical decision in sense of what? One is a reject null hypothesis, another one is a fail to reject null hypothesis, not accepted alternative hypothesis. Never you write down such kind of conclusion, statistical decision in your research paper or thesis, accept alternative hypothesis. In rather you write down fail to reject null hypothesis. Reject null hypothesis in this manner. So this is the a platform which I want to make, because otherwise we never understand the different outputs of the result. It's maybe the ANOVA in case of the regression or in case of the non-parametric. So there is a very simple question I want to ask any of you. Can you define me what is mean by parametric and non-parametric? Please tell me, anyone, what is mean by parametric and non-parametric? What is mean by parametric and non-parametric? Please, anyone?
सर आपका स्लाइड नहीं दिख रहा है।
अभी मैं बंद कर दिया ना। हाँ,
अच्छा।
I just want to question that what is mean by parametric, what is mean by non-parametric? Okay, look, parametric data set and non-parametric data set actually defined based on our what? Based on the distribution pattern, the nature of the distribution. Whenever the data follow the normal distribution, then it's called the what? Normal distribution. Sorry, parametric distribution of the parametric data. When the data set doesn't follow the normal distribution, then it is called the non-parametric analysis. Okay, non-parametric analysis. So what is mean by parametric analysis? When the data set, the distribution of the data set actually follows what? Like a bell-shaped curve. This is actually follow the Gaussian distribution, where the mean, median, mode all are same, where the mean, median and mode all are same, then it's called the normal distribution. So how can we check? In a software like Jamovi, which is the extensions of the R software, where there is an option you can check the assumption before you're going to analyze any kind of analysis. So when you try to conduct any kind of analysis, you have to keep in your mind one thing: what is your null hypothesis, what is your alternative hypothesis, what is your level of significance, nature of the analysis. It's maybe the one tail test, it's maybe the two tail test. Another one is whether the data follow the assumptions or not, because if it is follow the assumption, then we only consider a particular analysis, otherwise not. Otherwise not. So next become a particular concept like t-test, z-test. One minute. So t-test, z-test, ANOVA, these three are actually associated each other. How far they actually associated each other, and how far this is actually different from each other. Another one is a chi-square. Another is a chi-square. So first, we have to understand what is the informations actually we have for the hypothesis testing. Informations mean informations related to the mean, related to the standard deviation, related to the number of sample, or you may say sample size also. Sample size also. When mean is known but standard deviation unknown, number of sample or sample size less than 30, then we consider the t-test. Then we consider the t-test. When mean is known, standard deviation is also known, number of sample size is more than 30, then we consider the z-test. But these two particular tests actually analyzes the mean difference between groups. Mean difference. ANOVA is the advanced kind of analysis in sense, if you find out a data set within the group data set, suppose there is a different kind of label like nitrogen, particular fertilizer, applications of fertilizer is a nitrogen, phosphorus, potassium. This is a group of the fertilizer. And then we try to understand how for the applications of urea in sense of the nitrogen, in sense of phosphorus, which actually helps to the growth of the plant and the extension of the root as well as the development of the root, how for the potassium actually improved in sense of what? Improved to the crop size, number of crops in a particular bunch. Then we can consider the ANOVA. So in t-test and z-test, there is only two concepts, two groups, A, B, nitrogen, phosphorus. In case of ANOVA, where a particular group is more than two level, three kind of fertilizers are there, three kind of agricultural techniques you applied, tillage, no tillage. You may be considered is a case of the conservation process, how the conservation process actually rested the soil more, contour bunding, slope bunding, yeah, maybe the contour plugging, so etc. You can compare which particular method is a more important, effective in a particular sense of your research. So then you consider the ANOVA. So when the level is more than 2, then you consider the ANOVA. Chi-square is actually what? chi-square actually a non-parametric test. Non-parametric test. Even while we going to calculate anything, then we also consider one more thing, that is called the measurement type. That is called the data measurement type. Data measurement type. One is a nominal. Nominal means name, village name, plot ID, etc. Ordinal means order. Maybe you consider the Likert scale, 5-point Likert scale, 6-point Likert scale. Another one is called the interval data set, means a quantification. The temperature range is 18 degree to 20 degree. What is the impact on how this particular range of temperature impact on the agricultural productivity, vegetation health, crop health. Another one is called the ratio data set. So this particular first two data set, nominal and the ordinal, actually comes under what? The qualitative data analysis. In case of interval and ratio data set, this actually comes into what? In sense of the quantitative analysis. So whenever your data set is a qualitative, then definitely you go for the non-parametric analysis. Please try to understand, if your variable is a nominal or ordinal, if your variable is a qualitative in sense, definitely you have to select what? You have to select non-parametric analysis. Whenever you have data in a quantitative, and obviously this particular data distribution follows the normal distribution, then you can consider parametric test. I'll give you example. Parametric test, you choose t-test. Non-parametric test, Wilcoxon rank test. In case of z-test also, ANOVA. If there is a ANOVA, if non-parametric test, then you can choose the Kruskal-Wallis test. If this is the repeated measures, you try to compare the before and after situation, then you also consider what? Kruskal-Wallis test. Chi-square itself a test of what? Itself a test of non-parametric analysis. So this is the most important foundations you need to investigate. You need to identify hypothesis, data characteristics, whether the data distribution is normal or not normal, means parametric or non-parametric, because these are assumptions. Whenever you're going to conduct any kind of statistical analysis, definitely you have to investigate the assumption. Otherwise, your test indicate the different conclusion of the interpretation. So let's dive into the analysis part. This is the basic theory part. Along with this, we also try to understand how we can interpret our result. What is the assumption? What are assumptions are there? Okay, so please quickly remember the different assumptions, nature of the data set, measurement of the data set. These are very important steps before we going to conduct any kind of analysis. Suppose if you have a data set like this, नया data set लेते हैं. Look here, measure type, nominal. Click on the drop down, nominal, ordinal, continuous. So interval data and ratio data consider as a continuous variable. So definitely your value is in a continuous formation. Integer value, you may consider the integer value, you may consider the decimal value. Integer value, when you consider the integer value, when there is a 56, 57, 58, 59, 65, 69, like that. If your data set like 56.75, 59.35, then you consider the decimal. And please remember and keep in your mind that this is the initial stage of your analysis, and this is the must doing step in your analysis. Otherwise, you never conduct or implement any kind of analysis. Software packages doesn't matter. If you have a knowledge, you can access SPSS, you can access Jamovi, you can access Stata, even R also, because there is a lot of AI tools are there. You just go and write down the prompt. Please give me the code for the R for ANOVA analysis. You done. You can, but you have no idea what is actually the data set you need. Requirement of the data, what particular data set you actually needed for such kind of analysis. So that is the basic informations, foundational informations you have to remember before you go into analysis. So continuous integer, okay. This is the production. I think this is the productions. Okay, write down here the name of productions in kg. Go to the analysis, t-test, independent sample, sorry. Yeah. One sample t-test. One sample t-test. Why it's called the one sample t-test? Because there is only one result, production. And what is your objective? Your objective is that you're going to find out how for the value, how for the production of agriculture, some agriculture production per hectare in a different plot, across different plots. Suppose you have a 10 different plot, and you have also a data set of agricultural productivity. So you try to establish that this particular production is different from each other. Then you consider what? One sample t-test, because there is only one sample. It's try to measure a value from the mean value. How for the separated observation value is actually differentiated from the mean value. This is the production. Simply click, and in case of, okay, you just put here, look there, assumption check. First is the normality test and the QQ plot. This normality test and QQ plot, both analysis consider what? Both analysis indicate the level of normality. Is a mathematical way, normality test by Shapiro-Wilk test. And QQ plot is a graphical plot. So this is a quantized plot. If your all value plotted along this particular line, then you can consider, oh yes, my data is follow the normality. But the deviation from the line is more, then you consider, yes, there is a non-normality. There is a no normal distribution is there. So you can consider non-parametric analysis. If you find out the value actually follow this line, then you can consider what? Normal distribution. So you can further know from this particular statistics, if the p-value is 0.005, then you may consider this is actually the near normal distribution. Because in that particular sense, in case of the Shapiro-Wilk test, if the p-value is greater than 0.005, it actually consider what? It actually consider a normal distribution. If the value is less than 0.005, then it is actually consider what? That is actually consider not normal distribution. Okay, why? Because based on the hypothesis. In case here, what is actually the hypothesis? Hypothesis is, in case of normal distribution, the hypothesis H naught, null hypothesis, null hypothesis, null hypothesis, there is no normal distribution. So look, if your value is less than 0.005, then it's actually indicate what? null hypothesis is significant. So there is a no normal distribution. So that's why we consider here, if the value is more than 0.005, then data follows normal distribution, and then you definitely consider as a parametric data set. Please, based on the null hypothesis. Here, the null hypothesis, in case of normal distribution, there is no normal distribution. This is the null hypothesis, because we know from our earlier section that no difference, no effect, no is actually associated with the null hypothesis. And when we accept or fail to reject null hypothesis, when the p-value is less than our critical value, means the level of significance here 0.05 means at a 95% significant level, if the p-value is less than 0.05, it's interpreted that it's indicating that what, that we have to choose, we have to accept null hypothesis. But please look here, what is actually defined by null hypothesis? There is a no normal distribution. And that's why please try to remember and keep in your mind, whenever you consider this normality test, if the p-value is less than or equals to 0.05, then it is actually indicate what? No normal distribution. So data, the p-value should be more than 0.05. Then it's considered what? Normal distribution. So when you sanguine, when you assure that yes, my data set actually follow and as per the assumption, means the normality is there, this is the parametric test, then we select the student t-test. We select student t-test. If it is not, here the value is a 0.005, means it is a not normal distribution. So you just click on the Wilcoxon test. So non-parametric test is actually not a different concept, is not a separate pathway. It has not a separate pathway. It is actually run along the, is a parallel analysis. If your parametric analysis is violated, if the assumptions are violated, then you have to shift where non-parametric test, then you have to consider the non-parametric test. If your assumption is not violated, then you have to consider the parametric test. Is it clear? Please write down in a chat box, please. Then I move forward in details each and every analysis. Please write down in your chat box whether is it clear or not. It's give me more motivation. Please write down in your chat box, is it clear or not? Okay, all right. Thank you for your response. Please respond in between the time. Okay, that helps me a lot. You guys are understand clearly. So in case of one sample, we try to find out the mean difference of individuals. Okay, agricultural production in that particular sense here. So from the QQ plot, you look here, QQ plot, the value is deviated. So it's a non-parametric. That's why we click on where? Wilcoxon. Test selection based on the data. Continuous data, but non-parametric. Select what? Wilcoxon rank. If there is a qualitative data, let's consider that you are collect the data or arrange the data in a Likert scale. So this is the 1, 2, 3, 4, 5. 5 means strongly accepted. 1 means strongly rejected. So such kind of Likert scale we are going to use while you are conducting any kind of research, the socioeconomic research or any kind of qualitative research. So in that particular sense, we also consider the non-parametric analysis. So here Wilcoxon rank test, select on the Wilcoxon rank test, then hypothesis. Hypothesis is what? There is a difference. Okay, there is a difference. So that's why, look here, we only select one thing that is not equals to test value. And here we consider the value is 0, means from all the plot, the production actually more than is not equals to 0. It's not equals to 0. You may be changed here. You may be changed here. Suppose you have some historical data set. If you have some information that that particular region, the mean agricultural production is a what? 10 kilogram per hectare. So you can consider this value here and you can check whether your all the observation, all the outcome from the different plot, whether it is equals to 10 or not equals to 10. Main difference, also click on the confidence interval, effect size, confidence interval, effect size, as well as click on the descriptive plots. So you now you remove the tick off the what? The assumption check. So from here, you can find out this is your result section. Okay, this is the Wilcoxon result section. Statistics is a value of this W value. Look here, 0.01 means it's actually indicate what? Less than 0.01, it's actually indicate what? It indicate that your null hypothesis is significant. So there is null hypothesis is significant means there is no difference. There is no difference. Alternative hypothesis, there is a difference. But while we are going to write down anything in sense of null hypothesis or alternative hypothesis, we exactly write like this. Mu equals to 10 in case of here, or mu not equals to 10. Not equals to 10. Okay, mu equals to 10, not equals to 10. This is the null hypothesis. This is the alternative hypothesis. Look the result table. Look, note H naught mu not equals to 10. So definitely there is a difference from the mean value like 10. Or you can say this is the hypothetical value 10. 10. So how can you interpret this? There is a significant difference from the historical agricultural production, that 10 kg per hectare. Okay. As well as you can find out from this particular table what the effect size difference is. What? This is called the Cohen's D. Sorry, in case of here, rank biserial correlation. So rank biserial correlation is a 10. 10. That is indicate what? Yes, there is a significant difference from the historical or the hypothetical value of this particular plot outcomes in sense of agricultural production. And you also mention in your research paper that particular analysis also here, plots. Another test in the t-test, this is called the independent sample t-test. Look, there is a dependent variable and grouping variable. Suppose you have a two kind of plot. One is a normal plot, another one is a treatment plot. Treatment plot, you consider, you apply some mechanisms, etc. And now you going to analysis how for this particular treatment is effective in sense of agricultural outcomes. So we need a different kind of variables, like this is called the plot nature. One is a treatment nature. So I write down here as a T, and this one is our normal plot. So this is called the N. N. Now you can observe how far your application is, maybe the fertilizer, it's maybe the mechanism, it's maybe the machines, it's maybe the all stuff which actually try to enhance the agricultural productivity. Then go to the analysis, t-test. This is called the independent sample t-test. Production in grouping variables B, and then you check what? Also check the homogeneity test and the normality test. Homogeneity test means, homogeneity test actually indicate what? This is a case of the variance. Variance means how far the data set itself deviated from the mean value, the central value. So this particular test is called the Leven's test, homogeneity of variance test, Leven's test. So whether your data is a 0.804, so a low p-value suggests violation of the assumption of equal variance. So there is a no equal variance within the data set, within the particular group. Equal variance, there is a no equal variance. That's why nowadays Jamovi is a more user friendly, because you can understand your result and outcomes from the note section. Here you look, a low p-value suggests a violation of the assumptions of normality also. So when your data doesn't follow normal distribution and equal variance, definitely you consider what? Non-parametric test. Non-parametric test. In case of variance, no equal variance. Non-parametric test, Mann-Whitney U test is a preferable, suitable, appropriate test. If there is an equal variance, but non-parametric, you can consider the Wills analysis also. Click on the Mann-Whitney test, cross the assumption, check. Yes, hypothesis is group 1 not equals to group 2. Okay. Why? Because we try to find out the difference between their production. Is it equal or not? If we have a hypothesis that treatment plot have a greater agricultural productivity than the normal plot, then we click here. Group 1 is greater than the group 2. If it is less, then we select the group 1 less than group 2. So that's why in my lecture, I just started with the hypothesis testing, because without the foundational knowledge or the fundamental knowledge of hypothesis testing, you never interpret the data set. You never select the absolute or appropriate or suitable test. Look here, you just Mann-Whitney test, the p-value is 0.629. Here note H1 alternative hypothesis indicate. So there is a significance, there is a not equals to, means there is a significance difference. So yes, your application, your agricultural applications using of fertilizer, using of pesticide, using of mechanism, using applications of different kind of mechanics, it helps. It enhances the agricultural productions. It enhances agricultural productions. So from the alternative hypothesis, you find out that yes, there is a not equal agricultural outcomes, means there is a significant difference. So please try to understand not equals to means you have to write down, yes, there is a statistical significance difference between the two plots in case of agricultural productivity. Otherwise, you may interpret that there is a significance impact of agricultural associated or the different kind of methods which further increase the agricultural productivity. A simple test. You can easily download the Jamovi. It's an open source software. It's an open source software. You can easily download. You can put the data set, but you never interpret, you never choose the select analysis, because you have, if you have no further knowledge, if you have no basic knowledge which particular data set is it, What is the nature of the data set? What is the nature of the distribution of this data set? Okay, suppose is it normal distribution, then just equal variance, you click on this and you find out this particular test. So student t-test, a parametric test where equal variance is there. If there is a normal test but not equal variance, then we select the Wills test. Not randomly select all the menu, all the tests at a glance. Here you can find out another test is called the pair sample test. Pair sample test means, suppose if you have a one field, one particular plot, or few plots are there. You try to find out same things. What is actually the production before the application of agricultural intervention and after the agricultural intervention? In the same plot, there is another plot. In the same plot, in a different season, you consider data set, look, pair variables, only continuous variables. That's why Jamovi is a most preferred by the researcher nowadays. Continuous variables. So your data set look like what? Suppose this is your one production. You consider another data set like 85, 89, 87, 85, 69, 32, 69, 87, 45, 6, 62, 63. Like that. Then you consider here come this particular data series before agricultural intervention, agricultural productivity before agricultural intervention, and this one is the after. Go there. Look, one thing. Whenever select on the t-test, pair sample t-test, look here. One data is appropriate, is ready for your observation analysis. Look here. No. So check this as per the actual measurement types. So go to the data, click on it, setup is a continuous variable, integer, yes. Then you go to the analysis, t-test, pair sample t-test, and you consider production and see. Same process. Here you also check the normality and normality test. Definitely is a normal distribution because the value is more than 0.1, 0.142. A low p-value suggests a violation of the assumption of the normality. QQ plot, look at this plot, and then you consider what? Okay, my test is ready, and I'm going to prefer whenever the data set is a parametric student t-test. So here alternative hypothesis is not equals to 0, their measurement. So there is a significant changes in agricultural intervention, significant impact on agriculture production. If it is not parametric, non-parametric data set, then you select the Wilcoxon rank method. Result is same, interpretation is same, but according to your nature of the data set, according to the assumption, you have to select a particular method. Here you can use the different kind of mean difference, effect size, descriptive plots also. This is the descriptive plots. This is the C. This is the mean value, where at the 95% confidence interval, and this is the median value. So you find out that the mean value actually different, and the C has a more mean value than the production value. So before production values, mean value is less than the after value. Also the median. So you can also interpret from these particular graph, yes, there is a significant impact of agriculture intervention on agricultural outcomes. Is it clear? Please tell me in the box, text box, please write down. Is it clear? Okay, let's move on the ANOVA, one-way ANOVA. So ANOVA only suitable and approachable while we have a group. And my suggestion, my personal suggestion, whenever the group, the level of the group is more than 2, then definitely you consider the ANOVA, otherwise not. Otherwise not. So here production, the dependent variables, and this is your group data, group variables, and you can find out yes. And also you check this particular part, if is a assume the equal or the assume the doesn't assume equal or assume equal. So this particular test is called the Wells test, and another call is the Fisher's test. So in case of the not equal variance, then we consider the Wells test in case of the t-test or in case of the ANOVA test. Look here, yes, the value is a 0.804, so this value is a not equal. So here we consider the does not equal Wizard test. Descriptive plots, descriptive tables, okay, descriptive plots and descriptive tables, you find out yes, okay, there is a difference in between the two groups. And you can test further by the post hoc test. You know, unequal variance. So that's why you have to select here Games Hall test unequal variance in case of the post hoc test. And it is actually indicate that in between the two groups, there is a no as such mean difference in in agricultural production. Okay, so in that particular manner, you can use the ANOVA, one-way ANOVA. So first one, you have to definitely check the assumption check. Based on the assumption, here we only mention word. If the data set is a equal variance, then we consider the Fisher test. If it is a not, then the Wells test. But here is a question, sir. You are not actually mentioning the normality or the not normality case. When you have a smaller data set, like 30 sample, 50 sample, then you definitely go with the ANOVA analysis, whether the data is a normal, is not normal, or not normal. If the data set, your sample size is less, you can consider ANOVA whether your data distribution doesn't follow the normal distribution. Here we only focus on, in case of the small sample size, the variance. On the basis of the variance here, because ANOVA actually called analysis of variance. What is mean by variance? Variance is a deviation of individual observation from the mean test. Okay. According to this, we also post hoc test. So this particular result indicate that there is a no significant difference. This particular test also you find out the similar kind of test. This is a group data T. The mean value is 75.4, standard deviation is 19.3. Standard error means the standard. What is mean by standard error? Standard error means the standard deviation of mean of sample mean. Sample mean, then we calculate the grand mean, and the standard deviation of this grand mean is called the standard error. So that particular analysis also indicates that yes, there is a differences. But how far it's a significant difference or not? The post hoc test indicates that yes, there is a no significant mean difference. You may ask me, sir, why this is? Because if you go through this data, you find out that there is a changes of value 85, 89, 87, 85, 69, 32 is a abrupt lowest value by this range. The data nearly distributed from 69 to 90. Here in case of 9 n 54, 56, 52, 53, 59, 57, 87, 87, 84, 84. So abrupt data set, and that is why you find out a different kind of result here. So you can further in your research paper or in your thesis, you can easily write down why such kind of analysis actually, why such kind of result actually coming while you are attempting the ANOVA analysis. You can write down that within a particular group, there is a abrupt normal distributions, there is a abrupt value, maximum value or the minimum value that is impact on this. That is why we find out that what there is a no significant mean difference. Let's we change it and go for a further analysis. Look here, post hoc test 0.022. It indicates that there is a significant mean difference in agricultural production. And what is exactly the mean difference? 20, 20. How can you calculate the 20 from here? 75.4 minus 55.3, around what? 20 value. So that's why the post hoc test indicate the mean difference in respect of the t to t null with respect to the t of n is 20, and the p value indicates 0.022, which is less than 0.05 value. That is indicate yes, there is a significant mean difference between the groups. So in this manner, we can analyze the ANOVA. First, assumption check. Based on the assumption, we prefer the equal variance or doesn't equal variance. Doesn't assume equal variance of Welch test. If there is a equal variance, then we consider the Fisher test. Then we run the analysis and find out that particular graph and this particular statistical analysis. Okay, and ultimately you can decide, you can interpret, you can conclude, you maybe conclude in a sense of what there is a significant difference between the groups from where this post hoc test or the game by the games Howell post hoc test. Why you select it? Because there is a look here, because unequal variance. Why we consider the ANOVA? Whether the data set, the normal distribution indicate what? This is a normal distribution. This is the normal distribution 0.214. 0.214 indicate what? Is a more than 0.1 value. So definitely it is actually insignificant, the null hypothesis. So here we reject the null hypothesis. So there is a significant normal distribution and equal covariance. So definitely we check here assume test and Taki test. Same result. You may find out the same result, but this is the right process to analyze it, because the different kind of analysis, the options available based on the assumption. If it is valid, then you go there. If it is follow, then it is you can choose there. So when Games Hall test, when Taki test, you find out from your assumption test. Look, the value is a less than 0.01. So it is actually follow equal variance. That's why assume equal Fisher test. That's why you select here Taki test equal variance test. If it is not, then we consider the don't assume equal variance as well as the Games Hall test while we are going to conduct the post hoc test. Clear? Please write down in your text box. Text box, please write down. Is it clear or not? Okay. There is another test, is called the ANOVA. ANOVA. Suppose we use the fertilizer. Look at the data set. Okay, first you look here, ANOVA. Dependent variable. You only consider one dependent variable here, and there is a fixed factors. Means different kind of independent variables. In our data set, there is a, please try to consider, this is the different companies fertilizer. T companies fertilizer, N companies fertilizer. As well as here you consider another independent variables like irrigation, yes or no. Okay, so in case of yes, 1. What is our assumption and what is the objective? Now we look into the matter. What is this? How far the fertilizer and irrigation individually impact on the agricultural productivity, as well as how for their interaction. Interaction means a particular plot where we apply T company's fertilizer and also irrigated. What is the result? T company fertilizer, no irrigation. What is the result? N company fertilizer, irrigated in an irrigated area. What is the result? N companies fertilizer, not irrigated area. So we can also analyze these particular things by the applications of two-way ANOVA. Two-way means there is a two independent variables. One-way means one independent variables. Here we only consider what? One-way analysis. One way. Here we one way means there is a dependent variables are one, as well as one grouping variables. That's why it's called the one way. But in case of the ANOVA, here you consider the 2, 3, 4, 5 independent variables and try to find out the impact on the agricultural production. So production is your dependent variables, the nature of different companies, fertilizer, and D is the irrigation, yes or no. Definitely check the assumption check, homogeneity and the normality. Look here, 0.248. So no, doesn't assume equal variance, but you can consider what? Normal distribution. Normal distribution. There is the options of the model also. It only try to find out the impact of the B, means the different companies fertilizer, whether the land is irrigated or not, and how for the different brands of fertilizer with the irrigated or not irrigated area, how it's actually influence on the agricultural production. Okay, click on the overall model test, and there is a effect size, Cohen's d effect size. You also come. You can also find out, very interestingly, find out what is the difference in agricultural production where in between T and N company fertilizer. So go here and simply click the difference. You also consider level of difference in agricultural production, irrigated area, not irrigated area, as well as post hoc test. How for the difference is statistically significant in case of different companies fertilizer on agricultural production, irrigation, and their interaction. With the Cohen's d, it's actually indicate what? The measurement, the magnitude of difference. Magnitude of difference. Okay. So in case of Taki test is a possible for what? Equal variance. While there is a no equal variance, then you click on the Bonferroni test also. It is your job. It is your job. You have to find out what? Taki test, Skiffy test, the Bonferroni test, home test. What is the assumption? Don't go through any kind of statistical book. You just write down in the chat GPT. You write down in any kind of AI tools. Please give me the details, informations, and descriptions about the Taki test. Then question when or what are criteria for using the Taki test in post hoc test, home test, bin-office test, etc., etc. Even if you can also find out the estimated marginal means also. Marginal mean also. Consider the error bars also. So you can find out this particular analysis. So this is called the two-way analysis. Whenever you have a two independent variable, two-way analysis, three variable, three-way analysis. So overall model indicate that the value is a 0.240, means not significant. There is a no significance. There is a not significant difference in agricultural productivity. In sense of if you using different fertilizer, no, not significant. Not significant. Irrigated or not irrigated? Yes, there is a significant. Why? The value is a 0.09, means it is less than 0.1. So at a 90% significant level, please try to understand, at a 90% significant level, irrigation area, so applications of irrigation has a significant impact on agricultural outcomes. There is a mean difference. There is a statistical significance mean difference in agricultural productivity in sense of irrigation, irrigated land or not irrigated land. But while we consider the both interaction, there is a no significant. So what is your interpretation from this result, from this table? You interpret that whether we are applying different companies or different companies fertilizer, this doesn't matter. But if the land is irrigated or if the land is not irrigated, this is a matter. This is a sense. This make a sense here. So irrigation differ the agricultural production, and you have a domain knowledge. You know that. Why? Because the irrigation means water soluble. Water soluble, which actually dissolve the chemical components, which actually extract through the roots, and the particular crops, the particular vegetation, the particular vegetables, the particular plants, they consume their required nutrition. It also helps in case of sowing, in case of the paddy is important. Water logging condition is important from 1 inch to the 2 inch from the ground is important for the sowing of the paddy crops. So you can elaborate, you can describe, you can interpret lots of your knowledge by the evidence of this table. And even you go through this here, contrast n minus t, there is no significant result, but definitely 0, 1, 1, there is a significant result. In case of post hoc test, when t in between the n and the post hoc comparison is a b means the fertilizer. Is there any significant difference? Yes or no? Definitely find out here. The value is sorry, 0.095. Significant. Similar way, In case of the D, in case of the T, while a particular company's fertilizer, irrigated land, you find out the mean difference. Find out the mean difference. 0.317, no. 1.0, no. 0.956, no. So there is no as such significant importance or mean difference you find out in case of the using of different companies fertilizer in a irrigated or the non-irrigated land. Okay, this is a plot. So estimated the marginal mean values exactly between the analysis for 1 or the 0 when you applying the different kind of fertilizer. In case of the T, a particular group of agricultural production, in case of the N, T, fertilizer, in case of different fertilizer, and how for the irrigation and not irrigated actually define it is. Interaction plot, D into D interaction plot. So this is a ANOVA. This is a two-way ANOVA, three-way ANOVA. Okay, it actually helps you a lot. ANOVA is a very useful statistical techniques. Okay, just break for 2 minutes, only 2 minutes. Just please try to recapitulate from your learning, which we actually discussed. Just I need a 2 minutes break. So, have you any confusion, any doubt? Please write down in the chat box. Okay. Let's move on the regression analysis. Look, regression analysis actually indicate what? And what is the circumstance and what particular data set we need for the regression analysis. You maybe know one particular concept that is called the correlation also. But when we are considering correlation, when we considering the regression, first we start from here, one particular term, this is called the association. Then degree of association. And then cause and effect relationship. These three terms are very much important in case of while we are going to consider correlation, when we are going to consider the regression analysis. Association means maybe the organic material associated with the nutrients. When we call the productivity of soil, while we are taking consideration the fertility. What is meant by fertility? The naturally, normally, generally, the concentrations of different kind of macro and micro elements within the soil. So you know that a particular component is associated with the particular components. Why? Because there is a chemical bonding and the chemical relationship. Organic materials, where the organic materials is sufficient, organic matter is sufficient, that particular organic materials clubbed, they actually clubbed the nutrients, because organic matter act as a buffer analysis, as a buffer in a soil. So this is actually, we can say this is called the association. But you never say that what is the degree of association between the organic materials and a component. So while we are reporting the degree of association between two variables or among variables, more than two variables, then we actually prefer or going to calculate correlation. So in a correlation, there is a no independent variables, there is a no dependent variables. All the variables, we just try to consider how far they are associated with each other. And that particular coefficient value indicate you what? Indicates you there is a magnitude of association, degree and direction of association, degree and direction of association among the variable. Why? Because the correlation coefficient value lies between positive +1 to the -1. If the coefficient value indicate the positive value, means there is a positive association. And the coefficient value 0.569 means moderate positive association between A and B variables. -7.09 means higher negative association, means if a particular variables or components like or micronutrients or macronutrients like A is negatively associated with the B. So that's why in that particular case, whenever we are going to investigate the association, degree and direction of association, then we consider what? Correlation analysis. Two variables, simple correlations. More than two variables, multiple correlation analysis. But you want to understand that what is the level of impact of fertilizer application on the agricultural productivity. If you increase 1 unit of fertilizer, 1 gram fertilizer in your field, what is exactly effect on the agricultural productivity? So that's why it's called the cause and effect relationship. And here we are going to run regression analysis. So regression analysis is a cause and effect relationship. Is a cause and effect relationship. Is a cause and effect relationship. When you try to find out if you increase the x, if you increase the independent variable, if you increase the causes, then how far it's actually affects, how far its effect on y. If you increase a certain amount of fertilizer, then how far its effect on agriculture productivity. If 1 degree centigrade temperature is increased, how far it is actually impact on the agricultural productivity. Well, so in this context, we are actually considering the cause and effect relationship. This is the regression. In a simple regression, in a simple regression, we consider what? Y equals to A plus bx. So here x is a one causal variables or the independent variables. Y is a one dependent variables. This is a straight line equation. B indicate what? B indicate the slope. Slope, the coefficient, the nature of the contribution. A is the intercept value. If we are applying this particular fertilizer and we get this particular productions, what will be our initial value? What is our automatic production? It is actually indicated by A. That's why it's called the intercept, initial value, derived from your relationship between x and y. Suppose you have a independent value, variables more than one, then it is called the multiple regression analysis. A plus b1 x1 plus b2 x2 plus bn xn. This is called the multiple regression analysis. Here you apply more than one independent variables. Irrigation, yes or no? Fertilizer, yes or no? Pesticide, yes or no? Mulching process you actually applied in particular field, yes or no? You can consider as multiple linear regression. So definitely linear, this particular word actually indicate what? Linear. Linear means a direct relationship. Direct relationship. How can we implement in software? This is the production. Okay. I'm making different data. Just wait for time. Production, fertilizer amount 10, 12, 15, 18, 8, okay, 21, 26, 25, 24, 23, 12, 44, 20, 23, 29. Just randomly write down the data set. This is the amount of fertilizer. Continuous data set, integer value. Another one is a pesticide, applications of pesticide. Or maybe you consider this is the N, P, K, like this also. Go to the setup, click on continuous data set, integer, yes. Another variable irrigation. Definitely the nominal value also indicate the integer value. So if you have a independent variables in different measurement types, you also conduct the regression analysis. Irrigation, pesticide. Okay. Go to the analysis, click on the regression, linear regression. Dependent variable is a production. Fertilizer covariates. Look this symbol and look this symbol. Covariates, pesticide, and factors is a irrigation. Okay. Assumption check, autocorrelation, collinearity test, residual plot is important. Collinearity test means, is there any kind of higher intercorrelation between the independent variables? It actually checked by what? The collinearity test. You may find out a different terminology in the research paper and statistical books. This is called the multi-collinearity test. This multi-collinearity test actually analyzed by the variance inflation factor VIF. There is a different kind of rule of thumbs. If your data is a primary data set, then you can consider up to the 5. If there is a secondary data set, you can consider the 10. In a general sense, you find out the homogeneity of the value within the variance inflation factor. If you find out any kind of abrupt value, suppose 6.7 value of any kind of variables, in case of any variables, then you have to avoid these variables while you are going to conduct the regression analysis. In case of the Durbin-Watson test of autocorrelation also, but autocorrelation actually associated with the spatial analysis. So you may not consider the Durbin-Watson test for autocorrelation also. Let's check here. This is the model fit measures. R is a 0.589. This is called the multiple correlation R. Multiple correlation R. R square means coefficient of determination. Means however the independent variables actually explain Y. So from your result, 34.6%, near about 35%, these particular independent variables actually predicted, actually estimated 35% of your agricultural productivity. Means this model is not suitable. This model is not appropriate. Why? 35% means 65% is unobserved. So even your model, your variable is not explained more than 70%, more than 80%. So why you consider this model? Yes, one thing. If there is any kind of experimental research, you can consider them. But if you consider the established independent variables and the dependent variables is a well-known variables, then definitely remove this. Avoid this model. Never mention this model. You only go for the ANOVA. If there is any kind of levels are there, then you go for the another kind of test. This is the maybe the non-linear regression test. And nowadays people actually talking about the machine learning. The machine learning, a particular test where we find out what? The non-linear complex analysis. What is the base of the machine learning? Regression analysis. Non-linear regression analysis. That is the main base of the machine learning. We feed some data and then we call for what? Predict. You can also predict. You can also predict what? You can also predict the what? Amount of production from this independent variables with the help of the estimate. So here you find out what? Intercept value is 72.435. So if you are not change anything from your study area, the initial production of rice is 72.44 kg per hectare. The software find out the initial value, the intercept value, the minimum output of agricultural production while you are not checking intervention or not checking or applying any kind of intervention in this particular study area. You definitely get production about 72.44 kg per hectare. And definitely look, this 0.001 means there is a significant. But in case these three, fertilizer and pesticide, no. These two independent variables haven't statistically significant impact on the agricultural production from your data set. The model, that's why the determination, coefficient of determination is 0.346, 35% only, because only the irrigation actually statistically significant contribution. What? Where? Minus with respect to the one, the coefficient value of 0. If you irrigated more, production nature is different. So look here, you can consider the reference value. Look here, 0. More irrigation. 0 means no irrigation. 1 means irrigation. With reference to this 0 value, no irrigation. Agricultural productivity less, decreasing. How much? Near about 11 kg per hectare. Suppose you 1, look, the value is here. Same coefficient, same value, just change in plus and minus. This is called the what? This is called the multiple linear regression analysis. So in your result section, we have to mention this model fit measures, model coefficient production, and your methodology section, you mention the assumption check section. Assumption check. Lot of terminology is associated with this one. Regression itself need a particular day in terms of the webinar or workshop. Regression is not a very small concept, it's a huge concept. Homoscedasticity analysis is another assumption. Heteroscedasticity analysis. What is meant by homoscedasticity and the heteroscedasticity analysis? If the residual plot, look here, this is a particular plot which have a pattern. Is a pattern, means this is a heteroscedasticity. Suppose value is 65, what is the residual value? Value is 70, what is the residual value? 75 residual value. What is residual value? When this result is actually distributed and there is no particular formation, maybe the funnel shape, any kind of, then this is called the homoscedasticity. But this particular result indicate what? Heteroscedasticity. And heteroscedasticity is there in our research, and you know that is the main reason behind the low coefficient of determination. So we should change our variables if we really want to report this particular regression analysis. Different kind of regression analysis. Different kind of regression analysis. Based on what? Based on the dependent variables. Based on the dependent variables. Suppose your variables, suppose your dependent variables in a binary form. Zero, one. Irrigated land, non-irrigated land. Dependent variables in a binary form. Then we consider the logistic regression. Logistic regression. If your dependent variable recorded in a ordinal form, some order, some names are there, nominal variable there, then we can consider multi-nominal logistic regression. Ordinal logistic regression. If there is a heteroscedasticity, if there is a not linearity is there, then we can consider the ridge regression, lasso regression. Even there is a order more than 2, 1, 2, 3, 4, 5, 6 like that, maybe we consider the ordinal regression, or maybe we consider the probit model, probit, or otherwise it is called the Tobit model. All are the regression, but the nature of the dependent variables is different. Multiple linear regression in our example, continuous data set. But in case of binary, logistic regression. 1, 0, 1, 0, 1, 0. Multiple nominal data sets are there. You maybe consider geographical area. South India, North India, East India, West India. There is a production. How far the agriculture production actually different? Is there the geographical location? Geographical location has a meaningful impact on the production. You maybe consider here ANOVA, as also you consider the multi-nominal logistic regression also. This all the analysis actually depends on the odd value. ODD, odd value, means a probability analysis. If there is a no normality, then we go for the not normal distribution, non-linear regression, like the exponential analysis, logistic analysis, and nowadays we also consider different kind of model like random forest, decision tree, artificial neural network. Okay, then we can consider what? The gradient boost analysis, maybe the XG boost, maybe the light boost analysis, naive analysis. Naive analysis. So this particular analysis, actually nowadays researchers, they apply in their research to find out the complex relationship and try to solve this complex relationship. And that is why I think regression analysis needs a separate workshop. It's a special workshop for the regression analysis. need a separate workshop on the regression analysis. Okay, that's all from my side. If you have any question, any query, any kind of need any kind of discussion, you may feel free. Man candle test actually a trend analysis. If a data is a stationary, then we consider the man candle test along with the same slope test. Man candle test is a trend analysis. How far your data is actually upward trended or is the downward trended. It is we calculated, we apply man candle test in a sense of statistical analysis to find out the nature of the trend, whether the trend is upward or is a downward. But the same slope, along with this man candle test, the same slope, it is also indicate the magnitude of this trend. What is the magnitude? The coefficient, the degree by the same slope analysis. Researchers also apply nowadays the modified man candle test. Another test you consider here for the trend analysis, this is called the T-Sully's test. T-Sully's test. It is also find out a trend pattern. It also find out the nature of the stability, instability, fragmented, such kind of analysis. T-Sully's test is an alternative of this particular test. So lot of trend analysis is there. Regression is not actually indicate the trend analysis, is actually indicate the estimation, is actually estimate the effect of X and Y. Any question? Mann-Whitney U-test is a non-parametric test. Okay. This is also measure the mean difference between the groups. So whenever Mann-Whitney U-test, U-test is a non-parametric. So when data set doesn't follow the normal distribution, as well as doesn't assume equal variance. Which test doesn't assume the equal variance, but the data set is a normal distribution, then you can consider. Mainly, if your data set in a qualitative in sense, then you definitely go with the Mann-Whitney U-test. If your data set is a continuous, equal variance, not equal variance is there, then you can consider this one. So normality, non-parametric, not normality test. If there is a changes in any kind of variance, no equal variance, then you can say this one. Mann-Whitney U-test. So Mann-Whitney U-test is a non-parametric test. Non-parametric test in case of independent sample t-test or the pair sample t-test, where data set doesn't follow normal distribution. Which test consider when there is a no equal variance, is an alternative case of the student t-test in case of non-parametric data set. Is it clear? Sir, what is parametric, non-parametric? Parametric test is what? Parametric test means when data set follow the normal distribution. Then it is called the parametric data set. When the mean, median, mode are same. If you find out the Sapir-Whorf test, the p-value